We're going to move forward to our first topic. What we're going to talk about first is pavementdesigner.org, which is a free web-based concrete industry developed pavement design software program that's available to anyone who's designing roads, parking lots, intermodal facilities, and more. We are fortunate to be joined today by Eric Ferrebee. Eric is the Director of Technical Services for the American Concrete Pavement Association. He's responsible for research projects and was one of the leading developers of pavementdesigner.org. In this capacity, he's not only helped develop the software, but he's conducted several training sessions for it, and he continues to be on the team that constantly reviews and enhances the program. In addition to his work, Eric earned his bachelor's and master's degree in civil engineering from the University of Illinois at Urbana-Champaign. He also serves as the ACPA staff liaison with the Concrete Pavement Technology Center in Ames, Iowa. Eric has a wealth of knowledge and is a great presenter. Please welcome Eric Ferrebee.
Well, thank you, Art. Really excited to be here with you guys today and talk a little bit about pavementdesigner.org. Pavement design is something that I'm very passionate about. It's something that really has kind of gotten me into civil engineering. It's one of the reasons that I became a civil engineer, and it's one of the big reasons why I'm with the American Concrete Pavement Association, because I really enjoy concrete and cement-based pavement design. So today we're going to focus on pavementdesigner.org, which is an industry-based tool for designing concrete and cement-based pavements. And so this is a free tool developed by the concrete pavement industry for designing and building parking lots, city streets and local roads, intermodal type facilities. And we can do a lot of different things with Pavement Designer. So as I mentioned, pavementdesigner.org was made by the concrete pavement industry. So it was a partnership between the American Concrete Pavement Association, the National Ready Mix Concrete Association, the Portland Cement Association, as well as the RCC Pavement Council, trying to make a free and user-friendly tool for designing concrete and cement-based pavements. And so we can do, with this, we can do streets and local roads, like I mentioned, parking lots, intermodal industrial facilities, but we can also do a lot of things within that as well. So we can design for full-depth jointed plain concrete pavements, which would be our conventional concrete pavements that we see all the time. We can also design for continuously reinforced concrete pavements if we're designing something that's very heavily trafficked that may need some of that reinforcement. You can design for concrete overlays. We're seeing these become popular all over the country. So we can design using our existing infrastructure to take advantage of that as much as possible. You can also design using composite pavements. So anytime we're using a cement-based or stabilized substructure underneath, say an asphalt pavement, you can actually do that with Pavement Designer as well. But you can also do roller compacted concrete. You can design for cement modified soils or cement treated bases. You can also do full depth reclamation with Pavement Designer as well. So a lot of different things that you can do with Pavement Designer. And that's what makes it such a versatile tool and such a nice tool to have in your toolbox for designing concrete and cement-based pavements. Now, the concrete pavement industry really built this tool because we recognize that cities, consultants, counties, any type of engineer really needs a good, free, easy to access tool to design concrete and cement-based pavements. And we'll talk about one of the reasons why we recognize that need as we go through this presentation today. But there is really a need there for a good mechanistic-based solution for concrete pavement design. Now, we also developed this tool because we recognize that there's been a lot of turnover, not just at the DOT level, but at consultants and cities and counties as well. And we would really like to have a tool that professors can use at the college level to teach concrete pavement design, incorporate it into a pavements class to kind of get students exposed to how to design and design concrete pavements so that they're ready to go out into the field and start designing concrete pavements as well. Now, this tool is also a big benefit to the entire industry because it actually incorporates all of those different design methodologies that I talked about. You can design for joint and plain concrete pavements, continuously reinforced, RCC, really any type of concrete pavement that you want to design for, Pavement Designer can do. And that didn't exist before Pavement Designer. We had different tools that could do different parts, but Pavement Designer brings them all into one tool. So you can go to one place to design concrete pavements, and it's free. It's free, it's online, so you know that you're getting the best tool that's out there. most up-to-date software that exists. So making it free, giving everyone access to this full tool without having any restrictions on it is really something that was a goal when we were developing Pavement Designer. We released it in 2018, so it's fairly new, but the methodologies behind Pavement Designer are fairly old. These things have been around for quite some time, but they're still our best methodologies for designing cement and concrete-based pavements. So let's jump back to our map of what Pavement Designer kind of looks like in terms of what you can completely do with it. As I mentioned, you can do parking lots, streets and local roads, intermodal and industrial facilities. And in there, you can also do those overlays, RCC, continuously reinforced pavements, new composite pavements as well. But the reason why I spend a little bit more time on this map is to kind of reference what those existing methodologies are that have been incorporated into Pavement Designer. So if you're a pavement design geek like me and you want to know what's actually powering this design, is it something brand new or is it something that's been around for a while? This is a map that kind of shows you the existing design methodology that's been incorporated into Pavement Designer as our best practice for designing each of these types of facilities. So this map is actually available on Pavement Designer's resources section. I'll show you that as we go through the presentation today, but it's a good reference sheet to know what's actually powering the design of pavementdesigner.org. So we'll go through that a little bit as we go through here today. All right, so looking at our map, the first thing that we're going to talk about today is parking lot design. So how do we design a parking lot using pavementdesigner.org? So before we get to that, I always like to talk about what are the other ways that we can actually design a parking lot? What are the ways that you may have heard of or may be familiar with that kind of ring in your head before you think Pavement Designer, and how do they kind of compare? So the different ways that you can design a parking lot that exist that you may be familiar with are AASHTO 93, Street Pave, or ACI 330 design guides. So AASHTO 93 is more of a highway type design guide, and we'll talk about that when we go to streets and local roads, but it's not really something that trickles down well to parking lots. We also have Street Pave, which is, if you've ever heard of it, it's actually the predecessor for Pavement Designer, but that methodology has actually been incorporated into Pavement Designer as a part of our design process. So it's actually what's powering a lot of the designs in pavementdesigner.org. You notice that the PCA method was featured on that map in that previous slide. That's what was built into Street Pave, and then Street Pave was evolved into pavementdesigner.org, which is the free tool that now exists. But the thing that really is kind of made for parking lots besides Pavement Designer is these ACI 330 design guides that exist. So there was one released in 2008, and I believe they're still working on finalizing the current guide. But these design guides are fairly limited in what you can do. You're really designing based off of design tables. You can see some of what those design tables look like from the 2008 guide here. So you're fairly limited on what you can do. You have limited sub-base sections, so limited structural support, also limited subgrade supports as well. And you also have limited inputs in terms of the traffic type that you're seeing and how much traffic you're seeing. So you're limited in what you can really do with those existing design guides. So they're a good place to start if you've never designed a parking lot and you're looking for good information. ACI design guides have a lot of good information, but in terms of actually designing the pavement, it's a little bit limited in what you can do. Additionally, these ACI 330 design guides are actually based on the same methodology as Pavement Designer. So the 2008 guide was based on street pave design runs. The new guide that's just coming out is actually based on Pavement Designer design runs. So it'll actually be a one-to-one comparison if you're looking at ACI guide versus using pavementdesigner.org. It's actually the same design methodology. So Pavement Designer is really a robust tool for designing parking lot concrete pavements. Okay, so a little bit about Pavement Designer's methodology for designing concrete pavements. It's using a modified version of the Streets module that we'll see a little later on. And it's modified that way for a little bit for simplicity's sake, a little bit to be more focused on the type of loading that we would see for parking lot facilities. And so you'll see if you compare what you see in the parking module versus the street and local road module, it's a little bit different, but it's based on the same methodology. A little later on, I'll tell you the difference, the exact differences, so you can better understand that. But it does allow you for designing different design lives, different reliabilities, different percent slabs cracked, and these are things that you can't really control in those ACI design guides. So it's a little extra flexibility. All right, so let's take a look at a parking lot design using pavementdesigner.org. So we're going to keep it a really basic design where we're designing for a bus terminal that features, that serves about 50 buses a day. And we know that we have an existing subgrade that's a clay soil, fairly weak type soil, something that we typically see here around us in the Midwest. All right, so let's switch over to pavementdesigner.org. Okay. So if you go to pavementdesigner.org, as I mentioned, it's a free tool. So you can go to pavementdesigner.org and start designing without even creating an account. So you don't need to create an account to start designing concrete pavements with Pavement Designer. You just have to go to the website. Now, I have created an account. I've used it quite a bit because I do pavement designs quite a bit. And when you do create an account, all you need is an email and a password. We don't require any extra information. So it's fairly simple to sign up and create an account. The big benefit of creating an account is that you can actually save your designs online and you can access them from anywhere, any computer that you have. So it comes in handy. We'll see the My Designs features in a little bit, but let's go through and actually do that parking lot design that I just described. So first thing we have to do is start designing. So we go ahead here, click on Start Designing, and you'll see that we're brought to our first decision point. And so the first thing that we have to do is select what type of project that we're going to do. We can do a parking lot, street and local road, intermodal, or industrial type facility. So if you hover over any of these tiles, you'll actually see you've got a little flip screen. And it gives you a little more detail on what's featured within each of these modules. So the parking lot module is really focused on any type of parking facility. So any place where we have cars, buses, or trucks, this is where you really want to go. So even if you had an intermodal facility that was really just housing, really just used for loading trucks, you may still be in the parking module rather than the intermodal module. So I'll touch on this a little bit more a little later, but the intermodal module is really more for, say, forklift type loadings or really any type of non-over-the-load vehicle that would be featured in the parking lot design. So that's a little bit of the difference between the parking and the intermodal design. So we're going to focus on the parking design. We're designing for a bus terminal, 50 buses a day with a clay soil. That's all we know so far. All right, so we've selected a parking lot design module or parking lot design. You can see each design module within Pavement Designer is broken into a 3-step process. We have our project level details, our pavement structure details, and our summary details. So we try to keep it as simple as possible and focus on the critical inputs. So the first thing that we have to do within our project level details is choose our traffic spectrum. And so our traffic spectrums that are already loaded into Pavement Designer, we have ACI 330 traffic spectrums. And you can see when we start selecting spectrums, you can actually see the traffic summary details begin to change. And so the traffic spectrum that really corresponds to a bus terminal is ACI Spectrum C. That's corresponding to their new design guide. The ACI Spectrum C is directly corresponding to city buses. And so you can see here our traffic summary details. This is giving us the axle loads that our pavement is going to be exposed to, and the number of trucks, the number of those axle loads our pavement is going to be exposed to per 1,000 trucks. So if I had 1,000 trucks, my pavement would be expected to see about 18 single axles that had 31,000 pounds on them, and 23 axles that had 30,000 pounds on them. And then you scale that up for every 1,000 or for however many thousand trucks you have. So it's just a little background on the traffic summary details. Don't actually have to know that, but it's a good information to know. So the next input that I have is my design life. So here as a designer, I have to determine, do I want this bus terminal to last 20 years, 30, 15, somewhere in between there. We can really have flexibility here in terms of how long we want this pavement to last. So I'm going to choose 20 years for this design life. The trucks per day in this in this example would be 50 buses, as we've said that 50 buses is what we're designing for. So we have 50 buses per day. So 50 buses over 20 years is quite a few buses. So you can see how that would propagate out through these traffic summary details. So next we have is reliability and percent slabs cracked at the end of our design life. Here we have to kind of determine where we want to be, keeping in mind that since this is a low volume facility, that's also going to be a slow speed facility, we're probably going to have a lower reliability than we would say with a collector street or say an arterial or a highway. So our reliability is going to be a little lower than we would see in those types of scenarios. So here we're probably going to be somewhere around 75% for our reliability. And our percent slabs cracked is going to be somewhere around 15%, maybe 20%, depending on how conservative you want to be. So I'm going to say 15% slabs cracked at the end of my design life. So now that I've filled in all of my traffic and global details on the project level, I can move to my pavement structure details. Okay, so in my pavement structure details, I need a little information on the subgrade, the concrete materials, as well as the structural layers in between my concrete surface and the subgrade, so the sandwich layers in there. Now, all that I know about this facility that we're designing for right now is that I'm designing on an existing subgrade that's a clay soil, so it's not a very good support system. So in the parking lot module, you can see that we have a few descriptors that are describing various soils. We have this first one that's silts and clays. We have this one that's sands and sand gravel mixtures, and then sand gravel mixtures that are free of fine particles. So we know that we have a clay soil, so we're going to be in this low support realm, and we can just select that. And so when we do that, it's actually going to populate our subgrade CBR value and give us a resilient modulus. So if we actually have a subgrade value that we know, we can actually go in here and override that, say it's a CBR of 4. In that example, you can see how it's going to change where that support system is. I know that I'm going to design for a CBR of 3 in this example. Okay, so next thing that we need is a little information on our concrete strength and our modulus of elasticity. So we can define our concrete strength based off of a number of different factors. It can be a flexural strength, a compressive strength, and define it based off the modulus of elasticity, or the split tensile strength. So in this example, let's say that we know compressive strength. We're fairly familiar with concrete. It's going to be somewhere around 4,000 psi. And so I can define the design strength based off that 4,000 psi. You can see Pavement Designer actually calculates the flexural strength, and it's going to be around 580 psi. So we have these built-in conversions, but Pavement Designer is actually going to use that flexural strength in the design process. So that's, if you have flexural strength, it's best to just go with flexural strength rather than converting from these other strengths. But the conversions in here are fairly common and fairly often used. Okay, so the next thing that we need is our structural details, our structural layer, our layer information. And so you can see here, we can have 0 subbase layers, or we can actually put in a subbase between our concrete surface and our subgrade. So if we have a subbase layer in here, you can see that we can define it a number of different ways depending on what type of layer it is. Or we can just place the concrete pavement directly on the subgrade, which may be the case in some type of parking scenarios. So when we do that, it actually calculates the composite K value of the substructure. Basically anything underneath the concrete surface is combined into this composite K value. That's how we design concrete pavements. Okay. So we have our K value of our substructure. It's automatically calculated. We could override it if we wish. I'll show you that a little later on. But we've basically completed all of the main design steps before we get to the summary. So let's move on to the design summary. Now, once we get to the design summary, you can see that we've got a calculated minimum thickness, a recommended design thickness, and we've got a maximum joint spacing. We've got some sensitivity plots. So here's where we really determine, are we happy with our design? Or do we need to go back and change some of our inputs to kind of be more of what we would expect for this type of facility? So you can see our calculated minimum thickness is 8.14 inches in this case, and we have a recommended design thickness of 8.25 inches. The recommended design thickness is always going to round up to the next quarter inch. So here as a designer, we can actually look at this and determine, okay, should it be 8? Should we design for 8 inches, or should we specify 8.5 inches? We're probably not going to be anywhere, or we're probably going to specify on the 1/2 inch, So Pavement Designer is giving us that flexibility where we can see what the actual minimum thickness is that required for this design life and what our recommendation would be. So should we go up? Should we go down? Gives us a little flexibility in there. It also calculates a maximum joint spacing, and that's giving us our recommended joint spacing to make sure that our panels don't get too big where we might risk cracking. Okay, so these sensitivity plots are also very handy in terms of seeing how our design may change based off of some of our more popular design inputs. So the first one is that K value. That's defining the support underneath our concrete pavement. You can see that changing our K value does not have a hugely significant impact on the required concrete thickness. That's fairly consistent with what we see with other design methodologies as well. We know that the underlying layers are not having a huge impact on the concrete thickness. And so here we had about a K value of, I think, around 100. So if we increase that a little bit, we may cut off a 1/4 inch, a 1/2 inch, depending on the type of design that we're doing. So it's interesting to see how our design may change if we change some of the pavement properties as we went along. And so we can go back into our pavement structure and change the K value or the concrete strength based off of these properties and have an idea of what our what the pavement design is going to change to. So it's a fairly good tool in terms of what we can do with that. We also have we can see how the design life changes this. We can see how the reliability changes this. As I mentioned, we probably don't want to go too high with our reliability, as this is a low volume, low speed facility that's not seeing a whole lot of traffic. So we're in here around 75%. If this was, say, a collector type facility or an arterial, we may be up here in the 90 to 95% range, and we may see some additional thickness required. And then we have percent slabs cracked, kind of the inverse of reliability. If we want to have very few percent slabs cracked at the end of our design life, we're going to need some extra thickness. Of course, then we're not really failing the pavement at all anyway. Okay, so we also have cracking and erosion tables, and I'll talk about these when we go through a street design. And then we also have joint spacing. So this joint spacing is really basically giving you an idea of how this joint spacing was actually calculated. So where does that come from? Why are we recommending 15 feet? Why not 17 or 18 or 20? Or why not 14 or 13? This gives you a little bit of information on how that was calculated. Okay, so on Pavement Designer, you can actually generate a report as well. So if I generate a report, I can actually provide some additional information, design name. So in the parking example, you can just provide a designer's name, route, zip code, owner agency, a little bit of extra information. And then we can click download and view report. And if you have a pop-up blocker on, you'll have to disable that for Pavement Designer, and then you should get the, there it goes, loading a little slow. You should get the report right there on your screen, and you can actually see all the different layers and all the different inputs that we had throughout the design. It'll also download to your downloads folder as well, so you can have a copy of that design report. Okay, so if you're logged in and you've created an account, you can also actually save that or save this design, and that'll save the whole design for you. So you can see I already typed in the design name. I can choose a project folder, or I can create a folder and I can actually save it. And so if I want to come back to that and revisit later on or talk to somebody about it, I can save it if I've created an account, and then I can access it in My Designs. And so within My Designs, you can see I've used Pavement Designer quite a bit. I have quite a few folders with various examples through here. I just saved this parking example here, and you can see it's saved down here. And then so when I have those saved designs, I can either go in and I can edit those designs, or I can actually create a duplicate of it if I want to change one of those inputs and keep a copy of both designs. I can actually send this to somebody. So if I wanted to share it with Art and say, hey, can you take a look at this? You can type in his email address and it'll send him a copy of it. And then he can look at it and tell you what he thinks, or you can send it to me and I can tell you what I think. And then you can delete these designs as well. So you have a lot of features that you can access by just creating an account with your email and password, and that's all we require to do that. So it's fairly easy, and it's got some good extra resources there too. So speaking of resources, Pavement Designer has a fairly good library of resources that are related to pavement design. And so this is a good library of various resources related to pavement design, and it relates to all of the different types of designs that Pavement Designer can do. As I mentioned that map a little bit earlier, you can see the Pavement Designer map and methodology is right there, one of the first things that we have. We also have some intro videos in case you want to rewatch me going through one of these designs. We'll give you a little detail on how to do that. A lot of good resources from ACPA, from the Concrete Pavement Technology Center as well. So all of these are free, great things for relating back to pavement design. Alrighty. So the other thing that I want to show you guys on our first tour of Pavement Designer is the support section. And so this is a place where you can actually find the contact information of the national associations that kind of contributed to the development of Pavement Designer, as well as all of our state associations. You can find the contact information, say if you're designing outside of North Dakota and you're looking for arts counterparts somewhere else in the world, you can go here and you can actually find the contact information for those various states depending on where you're working on a design for. So another good resource on pavementdesigner.org. Alrighty, so that's our first tour of Pavement Designer and goes through the parking lot module. So let's see here, we've gone through the parking lot module. Next up, let's go in and talk about the street design module. Let's talk about how we design concrete pavement streets, and what all is featured within them. So, as I mentioned, with designing concrete pavements and streets within Pavement Designer, you have a lot of different things that you can design for. We can design for our conventional jointed plain concrete pavement. We can design for overlays, whether they're bonded, unbonded, on asphalt, on concrete, doesn't matter. You can design it with Pavement Designer, and it's fairly simple. We can also design RCC or continuous reinforced concrete pavement. We can also design composite pavements within here as well. So a lot of versatility within here. If we're designing a street and local road, we're doing full depth concrete or concrete as you see here in this picture. And we'll see how that looks in a little bit. We're going to focus mainly on the jointed plain concrete pavement here, but know that the same design process for jointed plain concrete pavement, you'll see basically the same 1, 2, 3 types steps for designing for each of these different types of facilities. You may just have some extra inputs that you have to deal with depending on the type of design you're doing if it's not a conventional full depth concrete pavement. All right, so similar to parking lots, let's talk about some of the other ways we would design municipal streets and local roads that you may be familiar with, and what some of the benefits and drawbacks are of those design methodologies. So here we're actually going to talk about AASHTO 93 for a few minutes. We're also going to talk about AASHTOWare's Pavement ME design tool, which is kind of a Cadillac, the best way to design concrete pavements that exist these days. There's also ACI 325 design guides and StreetPave. So let's go through these briefly and talk about what the differences are in these designs and what the benefits and drawbacks are. So our first one is AASHTO 93. And if you've ever done a pavement design, you've probably either used AASHTO 93 or at least heard of AASHTO 93. So AASHTO 93, as the name implies, has been around since 1993. It's nearly as old as I am, so it's getting fairly old, but it's actually way older than that. So AASHTO 93 is based on the AASHTO road test, which was performed between 1958 and 1960. So all of the observations that we had from that road test are what have been built into AASHTO 93. It's evolved a little bit over time with the 1986 guide, the 1972 guide, and the interim guide before that. But it's all still based on the AASHTO road test of the 1950s, which was performed in Ottawa, Illinois, close to where I'm at in Rosemont. It's about a 2-hour drive. So it's really based on that AASHTO road test where we basically built 6 test loops and we built concrete and asphalt sections. We loaded them for 2 years. We observed how they performed, and we built that into the design, the AASHTO 93 design equation. So all of that is based on the observations we had at the AASHTO 90 or the AASHTO road test. So it's very empirically based. It's based on those observations from those 2 years. So it's based on a very limited inference space. We had limited materials that were local to Illinois. We had limited structural sections because, as you can imagine, we had 6 test loops, so we didn't have an extensive amount of sections. We had, I think, around 360 concrete sections. So a reasonable number, but not huge. And again, local to Illinois with Illinois materials, Illinois soils, and we had 2 years of traffic data. So that's all we had. We had 2 years of traffic data. So not a whole lot of traffic information either. So we had limited structural sections, limited traffic, and limited observations. And that's what's built into the AASHTO 93 design guide. Now, you can see here some of the examples of the asphalt and concrete sections. Notice that a lot of the concrete sections were fairly thicker. This is because the AASHTO road test was, and the AASHTO design guides are really focused on highway type pavements that are built for interstate type facilities, highway pavements, very heavily trafficked roadways. So a lot of our concrete sections tend to be thicker. And you'll see why that's one of the drawbacks in a few seconds. You can also see some of the trucks that were loaded on the AASHTO road test. After those 2 years, they had about 1.1 million load repetitions of these types of trucks. So a fairly limited amount of data that we're actually designing with. Now, at the end of the AASHTO road test, here's one of the big problems with the AASHTO 90, the older AASHTO design methodologies. At the end of the AASHTO road test, about 30% of our concrete pavement test sections were failed. So 70% were still in decent condition. Now that's a big problem when you're doing a road test because you're trying to get a full performance characteristic history of how concrete pavements perform throughout their life. So if you don't fail your test sections, how do you know how your pavements are actually going to perform? And so this is a big problem with the AASHTO, the older AASHTO empirical design methodologies. They're based on limited inference space where we don't actually know how the concrete pavements are going to perform. So we had to predict how they perform. So we have different projections of how this would actually look. And now we're designing pavements for up to 100 million design or load repetitions. So way outside of the inference space of the AASHTO road test. And so that's a big problem with with using the AASHTO 93 design guide for designing concrete pavements is we really had to project how pavements were going to perform outside of the inference space. And so that's a problem. And so this was actually recognized by the General Accounting Office of the United States. You can see the title of this report, Highway Pavement Design Guide is Outdated. They're talking about the AASHTO 93 and the guides before that as well. It's outdated. We know that we can do better. And so that's why AASHTO created Pavement ME Design, the new pavement design tool for designing concrete and asphalt pavements. But Pavement ME is really made for federal and state agencies. It's made for high-level highway type pavements, interstate pavements. It's not really made for streets and local roads and parking lot types of facilities. So it's a great design tool, and it's really kind of the best way to design concrete pavements, but it doesn't really lend itself well to trickle down to smaller type facilities or agencies that don't tend to do pavement design a whole lot. It is fairly complex. You can see here what Pavement ME actually looks like. And there's a lot of information that goes into it, which is what helps make the design and analysis process more accurate. But if you're not familiar with the design process and you don't have all of the good information needed to run the design, it can become very complex and very difficult to do an accurate design. And that's one of the reasons why we don't see Pavement ME adopted. It hasn't been adopted by all of our departments of transportation. It also is not trickling down to cities, county highway departments, and some consultants that don't do pavement designs all the time as well. Additionally, it's fairly expensive. One license for 1 year of Pavement ME is around $6,000, so it's very expensive. But again, it's for more of the DOT type facilities, which is why we don't see it used all the time. Now, if we compare AASHTO 93 to Pavement ME, you can really see why it's such a better tool for designing pavements. You can see here how the inference space has changed, what the data that these methodologies are built on, how it's evolved over time. So if we look at AASHTO 93, it's based on that 1.1 million load repetitions. So that's the limited amount of traffic information that's built in there. Now we're designing for 50+ million load repetitions. That's why Pavement ME kind of has test sections all over the country, those long-term pavement performance sections. And we're actually evaluating how our pavements evolve over time. And so that's built into Pavement ME. It's kind of a really cool feature. Additionally, we had one set of materials local to Illinois in AASHTO 93. Now we have materials from all over the country, and we've seen how they perform in different environments. We have climate data from all over the country, not just 2 years of climate data from northern central Illinois. We also have structural sections, way more structural sections than we've ever had before, because we're building this off of data from all over the country from various long-term pavement performance sections. So we've really kind of blown up the inference space, and we have so much more information that Pavement ME is built on. Additionally, the ME part of Pavement ME is mechanistic empirical. So we've actually tied in the mechanistic predictions of how pavements are going to perform. And when we have that mechanistic prediction, what those stresses and strains are of our pavements and how we can predict the actual performance based off of those, and then tie it back to the empirical performance that we see in the field, that's how we get the best pavement prediction and best pavement analysis tool. That's why Pavement ME is such a robust tool for designing concrete pavements. However, it's complex and it's costly, and that's one of the big reasons why we developed Pavement Designer, because it's another mechanistic empirical tool that's not as complex, and it's obviously free. Now, again, it's more for streets and local roads. It's not for those interstate type facilities, but it can do those types of things as well. And we'll see that in an example here in just a few minutes. Okay, so another way that we can design for streets and local roads is the ACI 325 design guides. Now, these are very similar to the 330 design guides. We have our design tables. They're fairly limited in what we can do, but they will get you started in terms of what you're trying to do. But again, these are based on street pave runs, and the new guide is based on Pavement Designer runs. So it's actually using the Pavement Designer design methodology already. So that's great. So let's talk about Pavement Designer and where the roots are in terms of the design methodology. So Pavement Designer for roadways dates back all the way to the 1960s. So we originally developed this back in the 1960s. It's called the PCA method back then. It's evolved, and we've improved it over time. In the 1980s, there was a big step forward when we introduced erosion into the design model, and then we released it as street pave in the 2000s, and then updated again in 2012 to become street pave 12, and now we've released it for free as pavementdesigner.org, and it's featured within there. So it's a fairly robust tool that we actually look at failure criteria such as cracking and faulting or erosion, which is good because that's how our concrete pavements actually fail. If we revert back to, say, AASHTO 93, we're really designing based off of a serviceability index, which is kind of grouping all of the stresses together rather than actually looking at the stresses over time. So here we're actually looking at the stresses, cracking, and erosion. And this design methodology was more tailored for streets and roads. We basically recognized that the AASHTO road test was for highways, so we needed a design methodology for streets and roads. And so the PCA method was born. Now, Pavement Designer has actually been approved by the Minnesota Department of Transportation for their cities and counties. And this was a fairly recent thing. They actually just released this in November of 2020. They basically did a research study and looked at how it compared to their own in-state design module, which is MinPave Rigid, and they found that it was comparable, and so they allow for the use of pavementdesigner.org. So it's very exciting that your neighboring state is actually looking at using pavementdesigner.org for its intended purpose, its city streets and county roads, which is exactly what it's been built to do. So just a little aside there as well. So let's actually take a look. Let's design a municipal street with Pavement Designer. So we're going to design for Overland Parkway. We've got about 100 trucks per day, and we've got an existing subgrade that's a poorly graded silt. So let's take a look. All right, so if we go back to Pavement Designer, you can see that I'm still here in my saved projects. Let's go ahead and start a new design. See here, I've got if I'm going from here, I can actually enter my design right off the bat. Let's say Overland Parkway. I'm going to do a street design. And again, we have these flip screens, so if I'm not sure if I'm designing an overlay or a full depth concrete pavement or a composite pavement, you can see those flip screens give a little more information on what's featured within each of these modules. So if I go into my full depth concrete pavement, you can see that we're back to our 1, 2, 3 step process. So project level details, pavement structure details, and our summary details. So first thing that we have to do is select a traffic spectrum. Now, All I know is I have about 100 trucks per day. It might be a collector, it might be a minor arterial, I'm not really sure. So I'm gonna go ahead and turn on help screens. So you see this help question mark here on the top right, you can turn this on and off. I usually have it off because I use Pavement Design quite a bit. So you can turn it on. And so every time when we turn on the help screens, we have these hoverovers. They give us a little information about the input. But if we click on more information, we can see we've got a lot more detail on what this input actually is and what might be a good input for this type of facility. So I know I have about 100 trucks per day. So if I look in my traffic, my trucks, average daily truck traffic, I'm going to be in here. I'm going to be 100 falls between 40 and 1,000. So I'm going to say I'm a collector type traffic category. All right, so I know my traffic category now is a collector. You can see here I've got a little bit more a few more traffic spectrums within the street module. I can also add a custom traffic spectrum in here as well. So I believe you have to create an account and log in to do that because it saves on your account, but you can do it as well. Next thing we have to do is determine our design life. Again, we have to determine this as designers, determine what it needs to be. So I'm going to say 30 years. I know I've got 100 trucks per day. So the next inputs that we have are traffic growth rate, directional distribution, and design lane distribution. We didn't have these for the parking lot, so we've got to figure out what these need to be. So for traffic growth rate, if we're in an area that's growing fairly rapidly, we may be around 5, 6, 7%. If we're in a place that's fairly stagnant, it may be only 1 or 2%. So let's say it's growing fairly aggressively. Let's say it's about a 5% traffic growth rate is what we're expecting over those 30 years. And then directional distribution. So I've got 100 trucks per day. If they're split evenly going, say, northbound and southbound, I would say 50% of my trucks are in my design direction. If I know that all 100 trucks are in the northbound direction, I would say 100 trucks per day in my directional distribution, or 100% of my trucks are in my design direction. Similarly with design lane distribution, here if I say have 2 lanes going in my northbound direction, I may say that 90% are in my design lane and 10% are in my passing lane. You can see here if I click on my more information, you can see if I have, say, a 4-lane facility, 2 in each direction, I may have 90% in my design lane, 10% in my passing lane. So let's say I have a 4-lane facility and I've got 2 lanes in each direction. So I'm going to say about 90% of my traffic is in my design lane and 100% of those 100 trucks are in my design direction. So last thing we have are reliability and our percent slabs cracked. So let's take a look at reliability. No collector, it's probably going to be somewhere in the 85% range, which is exactly what we see here within our help screen. So about 85% for our collector would be a good idea as a starting point. And again, once we get to the summary, we can see how how all of these inputs impact the design, and we can change this with those helpful sensitivity plots. Excuse me. Alrighty, so the next thing we have is our percent slabs cracked, and it's going to be about 15%, somewhere 10 to 15% is usually pretty good. So one thing that we didn't have in the parking lot design that we have now in our street design is calculated traffic results. So this is basically taking that 100 trucks per day and that 5% traffic growth rate and those directional and design lane distributions, applying all of that over, say, 30 years and averaging it out for a daily traffic that it's designing for, about 200 trucks a day. And if we look at how many trucks over the entire design life we're designing for, we're at about 2.1 million. So that's what's kind of calculating through this design process. All right, so we filled all that out. We can go on to our pavement structure. Here we can determine if we're doing a full depth jointed plain concrete pavement, which is our conventional concrete pavement. We do RCC or CRC. So we're going to just stick to jointed plain concrete pavement. You'll see that if you play around with those other two, they're very similar in terms of what you're required to put to input. They're just designing for a slightly different type of pavement. Okay, so we know that we have an A5 type subgrade, but we don't actually have those helpful little click buttons that we had in the parking lot design. So if we turn our help screens back on and we look at what a resilient modulus would be for an A5 type soil, you can see that we have a good little chart here that can give us an idea of what, say, an A5 soil would be. So a resilient modulus might be between 5,000 and 8,000 PSI. So we could choose something in there, or we could choose a CBR value between 4 and 8, and that would roughly be about what we're looking for. So I'm going to be conservative. I'm going to go on the low end and say 5,000 PSI is my resilient modulus for this design here for my specified A5 type soil. All right. So next thing we need is some information on our concrete properties, our flexural strength, or compressive strength. Again, we have those handy little conversions. Here I'm just going to say I know I've got a flexural strength that's going to be around, let's say, 550 PSI. We need a modulus of elasticity. And then we have two little yes or no questions here that we can use for design. They are, do we have macro fibers in our concrete, and do we have edge support? So macro fibers in our concrete, this is something that we don't usually see with full depth concrete pavements, but if you're designing for an overlay or a thinner type, maybe a thin concrete pavement or a thinner overlay, you may see macro fibers used within your concrete pavement. If you're looking for more information on that, I'd recommend you look on the CP Tech Center's website. They've got a lot of information for designing overlays and designing overlays with fibers as well. Additionally, you can determine whether or not you have edge support. So edge support in Pavement Designer is defined as anything where you say have a widened concrete lane, say it's 13 feet wide and you stripe it at 12 feet, that would be considered edge support. Additionally, if you have, say, a tied curb and gutter or a tied concrete shoulder, that would be considered edge support as well. If you have an asphalt shoulder or a gravel shoulder, that would not be considered edge support. So in this example, I'm going to assume that Overland Parkway has a tied concrete curb and gutter, and so that would count as edge support. And so with that edge support, it's basically reducing the stress on that free edge, and so it's helping carry the load a little bit. So that's what's happening when we choose edge support for our design. So the next thing we have is sub-base layers. So here we can choose 0 layers and place our pavement right on the subgrade, or we can choose up to 3 layers for our concrete pavement. So let's say that we have 2 sub-base layers in this example. So the first one, we're going to choose, say, a granular base. You notice that we have some default resilient moduli in here, so it's fairly easy to select. And let's say the layer thickness is about 4 inches, a little thin layer, granular base. And then let's say we have a cement stabilized subgrade below that. And we're going to say we have, let's say, 5 inches of cement stabilized subgrade underneath that granular base. So now it's going to take that granular base, that cement stabilized subgrade, and our resilient modulus of our subgrade, and calculate a composite K value for us. So you can see here, it calculates it as 332 PSI per inch. If we wanted to override that and say, well, we think that might be a little high, we want something a little more conservative, we can go in here and we can say, okay, I want to use a user-defined K value of 200 PSI per inch. So now we've got 200 PSI per inch. That's what it's going to design with. We can move on to our design summary. Okay. So in our design summary, you can see here that we've got both doweled and undoweled thicknesses. So whether or not we're using dowels can be a decision that we have. We have our minimum thickness and our recommended design thickness. Again, taking that minimum thickness and rounding to the next 1/4 inch. And then we have our maximum joint spacing. So we have all of these for doweled and undoweled options. You'll notice in here that in this scenario where our recommended design thickness is 6.5 inches, we may not want to use a doweled pavement, at least maybe not our conventional round dowels. It may be difficult to get those within such a thin pavement. We may want to consider plate dowels or maybe fibers as an alternative, or maybe just do an undoweled pavement, which is likely what we would see being the proper scenario in this design. And so if we're looking for a little more information on whether or not we should use dowels, we can click on the load transfer tab, and we can see where we recommend using dowels, where they may not be recommended. And you can see what size dowel bars are recommended to use as well. So you can see less than 8 inches, we're likely failing via cracking, and so we may not actually need dowel bars, as faulting and erosion may not be a problem. So let's actually take a look at that. Let's take a look at our cracking report and see if cracking or fatigue is really driving our design. And you can see here in our cracking table that we've used nearly 100% of our fatigue life or our cracking life. And so you can see here which axle loads, these are going back to the project level details with the various axles that we're designing for. And you can see which ones are actually causing the most damage, which ones are consuming our fatigue life. And you can see it's mainly the heaviest of the single axle loads that are causing the most damage here. Tandem axles tend not to cause as much fatigue damage. If we look on the erosion, the faulting side, you can see here that we're not consuming a whole lot of our erosion life. And this is because we're in a doweled scenario. If we switch over to undoweled, you can see we see a little bit more faulting and erosion, but it's still not significantly high. So that tells me that we're really failing because of fatigue. We're failing by a cracking rather than faulting. So you can see here, tandem axles tend to be more damaging on the erosion side. Okay, so we still have all of our sensitivity plots. We have our load transfer tab. We also have that joint spacing tab telling you how this was calculated and why this is our recommended maximum joint spacing for this design scenario. So we've got a lot of good information to help inform the design that you're doing. So there's a lot of good information here as well. So we still have our generate report. We can also save if we've logged in and created an account, and we can go through in here and we can go back and change any of our inputs that we had, and go back and edit our design however we want. So a lot of good freedom in terms of what we can do with pavementdesigner.org. So let's go back to our presentation. Let's take a look at another design example. And so this is an actual design that I received, and somebody said, hey, can you look at this Astro 93 design and tell me if you think this is realistic, knowing that what we've seen over the years is that Astro 93 tends to result in overly conservative, unnecessarily thick concrete pavements for various types of designs. So the design that they had about 8,000 trucks or around 20 million easels, if you're familiar with Astro 93. Doesn't matter if you're not. They also had a 90% reliability with 5% slabs cracked. They had a 6-lane facility. They had an R value of 20, that's defining the subgrade. They had a modulus of rupture or a flexural strength of 630 psi with an elastic modulus of our concrete of 3.5 million. They assumed edge support, so they had a tied concrete shoulder or a widened slab. They had an asphalt subbase on a cement stabilized subgrade, and they assumed a K value of 160 psi per inch. Okay, so the Astro 93 design that was performed came up with 11 inches of concrete. So real quick, let's go through and see what Pavement Designer comes up with in this type of design. So let's start new design. Oh, don't want to save. Let's go ahead and start new design. Go ahead and start projects. I'm going to go to concrete pavement streets, full depth concrete pavement. And all right, so we're going into our design. So I've done this a few times, so we're going to go a little quick through this. So we have to select a traffic spectrum. It was a major arterial. Their design life was for 20 years. And they had 7,860 trucks per day. And they, I assume, say a traffic growth rate of about 2 or 3%. We assume directional distribution of 50% and a design lane distribution of around, let's say 70%. Based on our help screen, we know that when we have 3 lanes in one direction, about 70% of our trucks are going to be in that outside design lane. All right, so they specified a 90% reliability and 5% slabs cracked. So you can see here we're designing for quite a few trucks, 24 million trucks. Again, trucks not the same as easels, so don't be surprised that those easels and number of trucks don't quite line up. Okay, so if we move on to our pavement structure details, let's put in our subgrade details. They had an R value of 20, and they had a flexural strength of 630 psi, 630, and they had a modulus of elasticity of 3.5 million. So they did not have macrofibers, they did have edge support, and they had 2 subbase layers. Let's see here. An asphalt subbase layer at 1 inch and 6 inches of cement stabilized subgrade. Okay, so that's a fairly stiff structure. You've got an asphalt layer, you've got some cement modification of the subgrade. So it's a fairly stiff structure, but they were designing with a K value of 160 psi per inch. So being fairly conservative with that. So let's move on to our design summary with these design details. Okay, so you can see that with this design, our predicted minimum thickness is around 8.5 inches. So it's a fairly big difference from the 11 inches that we saw with Astro 93. Now I know that can scare off a lot of people, but that's typically what we see when we get into significantly high traffic volumed types of facilities, and using AASHTO 93, which wasn't really made for that type of traffic loading for the various reasons that we talked about a little bit earlier. So we have a pavement designer design of 8.5 inches, AASHTO 93 of 11 inches. How am I possibly supposed to understand the difference between here? Well, we've talked about some of the differences between AASHTO 93 and pavement designer. So let's see what pavement ME has. So pavement ME, again, is AASHTO's current design tool. It's their best design methodology for designing concrete pavements. It's something that we've really embraced as we've seen the benefits of doing mechanistic empirical design for concrete pavements. You can see here, the pavement ME design came out at 9 inches, so right around where pavement designer was, given those various inputs. And so I did both of these designs. I did the one with pavement designer. I did the one with AASHTO 90 or with pavement ME. And you can see with pavement ME, the cracking is kind of what's driving the design. It's what's getting closest to failure, but still they only predicted 9 inches of concrete was required for this type of design. So it's really great to see those two lining up because again, they're mechanistic empirical approaches to pavement design. So they result in pretty realistic numbers for the pavement design. All right, so the last thing that I want to touch on with the street design module, and I'm going to go real quick through this because I'm running out of time, and I've got one more thing that I want to cover, is there is a module within Pavement Designer where you can actually estimate the traffic given an existing asphalt design. So let's say that you have, that you're a county and you know that your typical asphalt section or the typical pavement design that you have is, let's say 3 inches of asphalt. Let's do what I've got printed here. 4 inches of asphalt on 8 inches of granular base. So 4 inches asphalt on 8 inches of granular and a resilient modulus of around 4,000 PSI for whatever you're designing for in this case. So if that's all of the information that you have, you don't typically do a pavement design, you typically just stick with that example that you have 4 inches on 8, that you may be used to using that, but you may also want to see what a concrete alternative might be for that type of facility. So if you want to do that type of analysis where you want to do a concrete design that's comparable to that, you can see in here, if we go to, let's say we've got a collector type facility and we know that we want it to last 20 years, we can go in here and instead of doing user defined traffic info, we can actually estimate it from an asphalt design. And so this is going to take that existing asphalt design that you may be familiar with, that may be what you always pull out at that 4 inches on 8. And it's going to create it's going to figure out how many trucks a day that pavement is going to hold given that 20-year design life. So I said granular base. The layer coefficient for granular base is usually around 0.14. There we go. 0.14 to 0.16. And then a thickness of, let's say, 8 inches. And this is going to be based on AASHTO 93 because AASHTO 93 is kind of the main design that's used for asphalt pavements for this type of facility. And let's say we've got a resilient modulus of 4,000. So you can see the other types of inputs that we need for an AASHTO 93 design. So it's going to actually calculate the structural number. It's going to calculate the flexible ESOLs. Then it's going to calculate the average trucks per day and the trucks over the entire design life. So it's calculating that based on that assumed 20-year design life that we have and the type of traffic that we have here. So it's basically saying that if we want this pavement to last 20 years, based on AASHTO 93, we would assume that it's only going to carry about 50 trucks a day. So that's kind of what's going on here. The liability was determined in there, and so beyond that, you'd have to provide a % slabs cracked, and then the rest of the design would be just like the design. Oh, I went too fast. Computer's lagging a little bit. So the rest of the design would be exactly how we show the design for streets and local roads. Okay, so I'm running out of time very quickly, and there's one last thing that I want to show you guys. It's the intermodal industrial design. Before I get to that, I should mention the differences between the parking lot design and the street design. I promised I would tell you guys that. So again, the parking design is a simplified design, so we have limited traffic spectrums. We also assume a growth rate of 0%, and directional and design lane distributions are defaulted to 100%. We also do not allow fibers, and we do assume edge support. So we assume all of that in the parking lot module. So if you copy these in your street design, it will exactly match up with the parking lot design. So that's a little bit on the differences between the parking and street design. Okay, so last thing that we're going to cover, we're going to talk briefly about the intermodal design. Now, before we get into this, or while we're getting into this, I should mention that we are in the process of updating this, making it a little more user-friendly. So if you've used it before, or if you're looking at it now, you may see that it's a little more complex than the other designs that we've talked about. But we are working on making that a little more user-friendly. So look for those updates sometime here in 2021. So intermodal design within Pavement Designer is really looking at designing for really heavy type vehicles like forklifts or container loaders. It's not really looking to design for over-the-road traffic like your conventional trucks. If you're doing a facility that's just designing for trucks, that's an intermodal facility, use the parking lot design or the street design. That's going to get you your best design. This module is really for these types of vehicles, your forklifts, any type of non-over-the-road vehicle that still has pneumatic tires that may be significantly overloaded. It's designed for those types of vehicles. So you can see the other ways that we can design these intermodal type or industrial type facilities. ACI 330 does have a pretty good guide that goes through how to design for these types of facilities and the things you need to watch out for. They do actually list ACPA Street Pave, which again is the precursor for Pavement Designer. They also list Pavement ME, which we've talked about. Great design methodology, not really great for designing for forklifts and container loaders and stuff like that. They also list TC Pavements and OptiPave, which is a good tool. It's not used a whole lot in the US, but it is used quite a bit in South America and other parts of the world. And then they list ACPA's AirPave. So ACPA's AirPave is actually developed for designing for aircraft, but it can be used for designing for these types of vehicles where you have some odd shaped loadings, odd tire and stress distributions. And that's what's actually used in the intermodal industrial design within Pavement Designer. And so let's do a real quick example as we're finishing up here. We're going to design for a Cat 986 loader, 130,000 pounds, 12.5 foot wheelbase with 10 foot axle width, and a tire pressure of 90 psi per inch, or 90 psi. Okay, so going back to Pavement Designer, let's go back to our home. We can start designing. Again, intermodal. So here basically goes, or our little flip screen tells us that we're looking at non-over-the-road traffic. We're looking at container loaders, excavators, any type of vehicle that has pneumatic tires that wouldn't fit in the over-the-road type traffic. So you can see here that we actually have a database of vehicles already developed within Pavement Designer. So you can actually select from these vehicles. You'll see the 986 loader that we're designing for right here. We can select that. We directly select on that. You can also create a custom vehicle. Now, to do this, you have to be logged into Pavement Designer, but you can create a custom vehicle. You can determine how many wheels this vehicle should have, where the position of those wheels are. First one should always be at 0, 0. You have to have a vehicle name. It's called Eric's Bike. You have to have the gross weight of the vehicle. I hope I'm not up to 30,000 pounds yet. And contact pressure and contact area. So there's an interrelationship between these three that you need to understand: the gross weight, the contact pressure of each tire, and the contact area of the entire thing. And that's one of the things that we're updating here in 2021 is this interrelationship will be a little easier to define, but it's not quite in there just yet. So let's stick to our Cat 986 loader. So that's the vehicle we're designing for. Then we can move on to our pavement structure details. You can see that we've got everything just like we've seen before. So we're going to go through this really quickly. We're going to put that right on the subgrade. All right, let's see what our design summary says for this Cat 986 loader. It says we need about 10 inches of concrete. And so you see that we don't have quite the other sensitivity plots that we had with the other design modules. It's one of the limitations of this design methodology, but you can see that we're basically, we've got the design thickness and the minimum thickness for this type of vehicle, and this is pretty much designing for however long, or for the entire life of pavement. And so that's another thing that we're looking to add in is number of load repetitions in case you have a vehicle that's not used every day. So we are looking at updating this, but you can use it right now and still play around with it and look at how the intermodal industrial design is done within Pavement Designer. And so with that, I think I'm just about out of time. I hope you guys have learned something about pavementdesigner.org today. If you do have any questions, please feel free to add them in the chat box, and Art can either pass them along to me or I can try to respond to them. Additionally, Brian Killingsworth, I believe he's on our agenda today. He's another great guy who knows a lot about Pavement Designer. He was on the solution team developing this tool. So a lot of good brain knowledge about pavement design. If you have questions, I encourage you to ask them or reach out to us after the fact, Art or myself. I'd be happy to answer any questions you have about pavementdesigner.org. So thank you. I'll turn it back to you, Art.
All right. Well, excuse me. Thank you very much, Eric. That was a fantastic presentation. A lot of information to cover there on a really great free resource that hopefully will be beneficial and used more with our pavement design community throughout North Dakota. We don't have any questions in the chat box right now, and so if anybody does have questions, either later today or next week, whenever, please feel free to reach out to me, and I will make sure that we get all of those answered, and we will follow up with you offline.